Hello, welcome to our channel. So my name is Tifla, guys. I'll be going through arithmetic sequence with you today. So let's suppose maybe you want to build the stairs, right? You want to build the stairs, and then maybe on the first stair you place one box like this, right? And then on the second stair you are like, okay, let me place 3 boxes. So it means that if I place 3 boxes on the second stair, and then you're like, okay, so this is my first stair, this is my second. So on your third stair you're like, okay, now let me place 5 stairs, 5 boxes, I'm sorry. So like that. So this would be your third stair, right? So it means that if you are continuing like this, it means that on your first stair you placed 1 box, right? On your second stair you placed 3 boxes. On your third you placed 5 boxes, right? And then on your fourth, so it means that you can see how this pattern is going on and on, right? So it means that here it will be 7 stairs. And then if you are placing on the 5th one, it means that there will be 9 stairs. Can you see that? And so on. So what we just created here, it is a sequence, right? It is a sequence. This is what we call a sequence, right? So before we dive too deep about this topic, about this arithmetic sequence stuff, let's find out what is a sequence. What is a sequence, right? So for a definition, a sequence is an ordered set of numbers or variables, right? An ordered set of numbers or variables. So it means that if we check on the previous example that I was giving you, we said on the first case, or on the first stair, we are going to put only 1 box, and on the second one we are going to put 3 boxes, right? And then on the third one it was now 5 boxes, and on the fourth one it was 7 boxes. So these are ordered numbers, right? These are ordered set of numbers, right? 1, 3, 5, 7. So let's write them clearly. So it will be 1, it will be 3, it will be 5, it will be 7, and so on. So it means that my sequence is having 1, 3, 5, and 7, right? So we use sequence in many different things. If you take a look at maybe clothes, the patterns that are on clothes or designs, they use patterns, right? They use sequences, just that we have different type of sequences. But today I'm just interested in dealing with arithmetic sequence or arithmetic progression or arithmetic pattern, however you can describe it, right? So now let's explore more about these arithmetic sequences. So a question can arise: what is an arithmetic sequence? How can you describe arithmetic sequence now? So arithmetic sequence is a set of numbers, or variables that are having a common difference. So they are having a common difference. So these numbers, we have a common difference between their terms, or between successful terms. I'm going to describe everything. So this is between terms, or we can rather say successful terms, or we can say consecutive terms. Between consecutive terms of their sequences, right? So let's take a look at this sequence, right, that we just created. So this is the sequence that we are having, right? So let's just describe all the necessary information that you need to know, right? So this is our first term of this sequence. So the first term of a sequence, we refer it as A. So this is our first term, A. So A is the first term of any sequence. So just because we're talking about arithmetic sequence, let's just say A is the first term of the arithmetic sequence, right? So if we check these terms, you can guess what comes after this term, right? Yes, it's a 9. And after this, yes, it's 11, right? So you can see what is actually going on here. So it means that from this term to get to this term, we added something, and that something it is 2, right? But now, how do we describe this now? We say now this is the common difference to move from the second to the first. So it means that to find our common difference of the arithmetic sequence, we say term number 2 minus term number 1. So this is term number 1 that we refer to as A, and this is term number 2. So this is term number 2, term number 3, term number 4, and so on, right? So this is T2 minus T1. So this is also equivalent to say T3 minus T2, right? So let's see. Our term number 2, it is 3. And our term number 1, it is 1. So it means that our difference, it is 2. And this is also the same as this side. So T3 minus T2. So this is, what is our T3? It is 5. So this is 5 minus a 3, which is 2. So this is referred to as the common difference. So the common difference of any arithmetic sequence is always the same, or it is always equal, right? How do I mean that? I mean, if I take T3 minus T2, I'll get the same value as if I take T5 minus T3. So generally, I'm saying Tn minus Tn minus 1 should give us a common difference. So no matter which terms we take, if we are taking consecutive terms and we subtract them, we'll get the same common difference, right? So let's move on. So what are consecutive terms? What do we mean by consecutive terms or successful terms? So it means that this term and this term, they're following each other. So these are consecutive terms. So T2, so this is our T1, T2, T3, T4. So T2 and T1, they are consecutive terms. T3 and T2, they're also consecutive terms, these two. And also T4 and T3, they're consecutive terms. So these are what we call consecutive terms. They are terms that are next to each other, or terms that are following each other, right? So as we are having these consecutive terms like this, what can you do if I say, what is the value of term number 8, for example? Can you find out term number 8? Yes, it can be simple because this is term number 1, term number 2, term number 3, term number 4. You can continue up until you get to term number 8. But what about if I say, find me term number 100? Now it can be a difficult task to continue these numbers up to 100 times, right? But since we do maths, we always find the general formula to solve anything, right? So it means that if we can try to find the general formula of this sequence, then we can end up calculating any term number in the sequence without a problem and without wasting time, right? So how do we find the general formula of arithmetic sequence? So this is what we do now. So since we say this is a, the first term, we all agree, right? And we said the common difference, it is this minus that, and which we found out it was 2. So also here it is 2, and also here it is 2, right? So now to find the general formula of this, we say Tn, and Tn stands for the general formula, or this the term of any value in this sequence, right? So we say Tn, and we say it is equals to a plus n minus 1 d. So this is how you find the general formula of any arithmetic sequence. As long as it is arithmetic sequence, then we use this formula, right? So what is the value of a according to this sequence? So the value of a according to this sequence, it is 1, right? Plus n minus 1. So we don't have the value of n yet, so it means that n, we are just calculating generally. So it means that if a question arises that calculate the value of term number 50, it means that on n we can substitute 50, right? So now what is our difference? Our difference is 2. So this 2 is actually multiplying everything inside. So let's just make it like this. So this now becomes 1 plus 2 multiplied by n gives us 2n. And then 2 multiplied by minus 1, it is minus 2. So lastly now, it means that our general formula of this sequence now becomes Tn being the same as 2n minus 1. So this is the general formula of this sequence. So let's see. So just like that question, I said, what is the value of term number 100? So it means that now we are solving for term number 100. So what can we do now? So it means that we can take our formula that is saying Tn is equals to 2n minus 1. So where there's n, we are substituting 100. So term number 100 becomes 2 times 100 minus 1. And this becomes 200 minus 1. And this is 199. So this is 199. So it means that our term number 100 of this sequence, if you continue this sequence up until to the term number 100, we are going to find that it is 199. Can you see now how we can use the term, the general formula to find any value of any term, right? Now here comes another question. They said which term number has a value of 399. So now, just like we did previously, we can say Tn is equals to 2n minus 1, right? So now this is the value, right? So remember that if we're having like our sequence that we're saying 1 3 5 7, right? So this is the value of term number 2. So term number 2 is equals to 3. So this is the value of term number 2, right? And if we move to this is term number 3. But what is the value of term number 3? It is 5. And when we move to this is T4. And what is the value? The value is 7. So right now we are having the value, but we don't have the term number, but its value is 399. So it means that now we need this, the term number. So it means that we can substitute this on this, right? So it means that our 399 becomes 2n minus 1. So now we are trying to solve for n. So it means that we can bring 1 this side. When we bring 1 this side, so this becomes 400 is equals to 2n. Now we can divide by 2. So it means that our n lastly becomes 200. So what does this mean? It means that our term number 200 is the value of 399. This is the meaning of that. So our term number 200 is the value of 399. So you don't have to confuse between the value and the term number. Let me re-explain this again. So don't forget that this is term number 1 and its value is 1. Term number 2, its value is 3. Term number 3, its value is 5, and so on. So these are the values of the term numbers that are there respectively, right? Yes. So how can we summarize everything that we did so far? So let me summarize everything in brief, and then I'll tell you the important aspects to take along. So we said arithmetic sequence is a sequence or a set of numbers that are having a common difference. So this is a property of arithmetic sequence. And we said A is the first term of the sequence, right? So it means that this is another property of arithmetic sequence, right? And we also use Tn is equals to A plus n minus 1 d. This is another property of arithmetic sequence whenever we are trying to find the general formula of any sequence, right? So now, are we able to use these properties to solve any question? Are we able to do that? Let's see. So we are having this sequence, and they said this is an arithmetic sequence. This is an arithmetic sequence. Can you find the value of x? Can you find the value of x? So we need the value of x if this is an arithmetic sequence. We don't have to worry much about this. We know that in any arithmetic sequence, the common difference is constant. So we are going to use this property of arithmetic sequence to find the value of x. So we are going to say term number 2 minus term number 1 gives us the difference, right? And also term number 3 minus term number 2 gives us the difference. Is that correct? If we say this minus this, we get the difference, and also this minus this, we also get the difference. But these differences are constant. They are the same, right? So it means that if this is the same and this is the same, we can equate these. So it means that we can simply say T2 minus T1 should give us the same as T3 minus T2. You should not worry about using variables. Variables are fun to use. If you want to love maths, or you want to be good at maths, always try to use variables, right? Enjoy using variables. Look for the questions that are having variables in them so much. They can help you a lot because using variables is more challenging, right? So let's see, what is our term number 2? It is x. So x minus our term number 1, which is 5, should give us our term number 3, which is 13, minus our term number 2, which is x. So now, what do we do now? We want to solve for x. It means that we can group the like terms. So it means that our x can come this side and this minus 5 can go that side. So if this comes this side, it will be x plus this x. It will just be 2x being the same as 13 plus 5 gives us 18. So divide by 2. So it means that our x is simply 9. So it means that our x here, it is 9. So our sequence now becomes 5, 9, and 13. Does this satisfy arithmetic sequence? Let's see. So what is 9 minus 5? It is 4. What is 13 minus 9? It is also 4. So this satisfies the arithmetic sequence. Can you see how we can do this? Yes, just like that. So right now we are having a typical exam type of question, right? So they gave us an arithmetic sequence, and the first question they said find the general formula. The second question they said what is find the value of T29, and then they said on the third one which term has the value of 97, and then the last one they said is 88 a term in this sequence. So let's just do this step by step, right? So we're having this sequence that is saying 7, 12, 17 and 22. So our value of A, it is this first term, which is 7, and our common difference there, it is 5. 12 minus 7 is 5, 17 minus 12 is 5, and 22 minus 17 is 5. So to find now the general formula, now we are going to say Tn is equals to A plus n minus 1 d. So what is our A? It is 7 plus n minus 1, and our difference is 5. So this becomes 7 plus 5n minus 5. So this is just 5n plus 2. So our general formula, it is 5n plus 2. So with this one we are done. So Tn is equals to 5n plus 2. And they said find the value of T29. So we are just gonna say T29 is equals to 5 and then 29 plus 2. So what is 5 by 29? What is it? It is 145, right? And then plus 2, this becomes 147. So we are going to have 147. So term number 29 is equals to 147. Can you see that? Let's continue to the next question. So they said which term has value of 97? Which term has value of 97? So it means that 97 is our value. So we use again the formula 5n plus 2. So our 97 is going to come here, and then 5n plus 2. Now we are going to solve for n. So it means that we can bring our 2 this side. So 97 minus 2, it is 95. N, and we divide both sides by 5. It means that our n is equals to 19. So this is T19, right? And the last question they said, is 88 a term in this sequence? So how do we do this one? Again, we use the properties, right? Let's see. So the formula still is Tn is equals to 5n plus 2. So let's substitute 88, 5n plus 2, and then we can bring 2 this side. So this becomes 86 is equals to 5n divided by 5 divided by 5. So our n now becomes 17 comma something something, I think comma 2 something, right? So now if we have found the value of n as a fraction, it means that this value is not a term in this sequence. So it is not a term in this sequence because this value of n will always be a positive number and also a whole number. So it cannot be a fraction. I cannot say find the term number 2,5. It's not possible, right? So this value of n must always be a whole number, and also it must be positive, right? So it means that 88 is not a term in this sequence because it gave us a fraction 17 comma something. Just like that. This is how you solve the arithmetic sequence. So next up, I'll just bring the complicated arithmetic sequence stuff just for you to have a look at, right, before I can do the quadratic sequence. So please like and share with your mates, and subscribe or follow if you haven't. Your follow and your share and your like, guys, will really support us. Thank you very much, and see you on the next one.